Hi guys, good morning. Welcome back to the next video. In this video, we will see the problem maximum width of a binary tree. It is one of the most easiest problem in terms of thinking, but one of the complicated problem in terms of edge cases. So yeah, before further ado, let's start with the problem statement itself. What the problem says, it says that we are given the root of a binary tree. As usual, we are always given the root of a tree. Return the maximum width of the given tree. How that maximum width is defined? It is the maximum width among all the levels, which means for every level I just check what is the width, and then for every level I just grab what is the maximum width. The width of one level, because I said for every level I need to find the width. Width for one level is defined as the length between the end nodes, which means the leftmost and the rightmost nodes. Let's say if the tree looks something like this, then listen carefully. The width of the tree right here will be nothing but the width of this level is nothing but the width from here to here, which means the leftmost node. It's not necessary that okay, it is the extreme left. It is whatsoever is in present a leftmost node to the rightmost node. It's not the right end, but it is the rightmost whatsoever the node is present here. It is what a width is of. Okay, it is guaranteed that the answer will be in the range, which means the maximum width is the answer, right? So it is in the range of integer, which is a 32-bit signed integer. Let's look at the problem examples pretty carefully. Firstly, if we just want to grab the maximum width of this whole tree, we know that we have to grab the maximum width of this tree. So we need to grab the width of each level. Each level width is 1 here, width is 2 here. Here you can see from start node to the end node, width is nothing but 4. 1, 2, 3. It is not present, but if it had not been there, so it had been null here. Thus, from start to end, the width is actually 4. Thus, the maximum width out of 1 to 4 is actually 4. So the answer is 4. In the next example, width is 1, width is 2, width is from here to here, the width is 4, because you can see it has right child, it has left child as null. So width is 4. Width from here to the end here, it is here it is right child, here it has 2 left and right child, here it has 2 left and right child. So the width is 7. Thus maximum out of all these, it can be 1, 2, 4, 7. It is 7. So while walking through example, one thing you might think is, Aryan, it's for sure that the last level will always have the maximum width. I will say no. Why? Because if you see this, first and the last node, it's itself this. Thus the width is 1. It is first and the last node. Thus the width is 1. Here you can see the width is 2. So for sure, okay, we need to go to every level and find out the width, and after that we need to grab the maximum width. We can't just go to the last level or any particular level. We have to go to every level and find the width and take the maximum out of that width. Answer is 2 here. So one thing for sure, we have to find the width for every level. Every level, as we have been seeing in the last videos also, every level when we have to traverse every level, thus we have to use a BFS, because see, we have to do a level wise traversal, which means traversing to every level, because ultimately we need to find the width for every level. Thus we will use a BFS. Okay, one thing we got to know, we will use the BFS. But for width in a BFS, we just can't count the number of nodes in the level, because we saw here the number of nodes in the level is 2, but the width is 4. The number of nodes in the level is 2, but the width is 7. So we can do a BFS traversal, but still we cannot find the width with that BFS, standard BFS traversal. So Aryan, what to do? I'll just say, have you looked at the problem itself carefully, or have you looked at something like this ever before, where the tree is represented in a form of an array? Which means, if anyhow you have ever, if you have ever encountered, then remember, if you have represented the tree in the form of an array, or if not, let's think, okay, of assigning this tree some values so that I can find my width of every level in that particular number. Okay, if I know the leftmost node has some number, let's say x, if the rightmost endmost node has, let's say, number some y, so I can find, okay, y minus x is the actual width of this node. But for that I need to place some numbers in the order of this tree. So let's place number. Let's have this whole tree as, let's make it right here. So I will just make it as, I just place some numbers that, okay, I can just find the width of this level in just O of 1, which means I'll just place number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You will see width of this is nothing but 1. Width of this is 2 minus 1 plus 1, because see, end, start, end minus start plus 1 is always the width. Here it is 6 minus 3 plus 1. Here it is 14, 12, 13, 14 minus 7 plus 1. Okay, Aryan, I just got to know, okay, we can just assign some numbers and then we can just find the width. But how to assign the numbers? I mean, okay, like you just went in the order of assigning numbers, but how will I assign when I will traverse in a tree? Because when I traverse in a tree, I just go from the root node to its child nodes, which means from this node, from the node right here, I'll just go on to these two nodes. From the node right here, I'll just go on to these two nodes. If you just carefully look, okay, if the node value is 1 right here, its child value is nothing but 3 and 4. If the node value is 2 right here, its child value is 5 and 6. So if I try to find some relation, I can easily find the relation. Okay, it is, if the node is I, so the child, left child is 2 into I plus 1 and the right child is 2 into I plus 2. It is how we build intuition that, okay, how we gonna number, why, firstly we thought why we gonna number this. After that we thought, okay, how we can build a pattern that I can build some numbers out of it. But remember this for sure in future also. It is how a tree is actually represented to you guys, which means if you look at the input itself, it is how the tree is given, and it's not this. If you just even go and look in segment trees, Fenwick trees, even when in exams, in college exams or anywhere, you're given the tree, you always have this input in a form of an array, which represents if 1 is a root node, its child is nothing but 3 and 2, which means if I is the root node, its child is 2 into I plus 1 and 2 into I plus 2. It is actually the input itself. If you carefully look, see, it is the input I into 2 into I plus 1, because the indexes is 0, 1, 2, 3, 4, 5, 6. If I just number this 0, 1, 2, 3, 4, 5, 6, you look what happened. It is how actually your tree was actually represented to you since you have started traversing your tree. Actually, I just say, okay, I have the root node, but actually it is how the tree is represented in the form of an array. So, okay, ultimately, you know that from root node, which is I, you can go on to the left child as 2 into I plus 1 and the right child as 2 into I plus 2. By this, you can just number your levels, and by this numbering of levels, you can just know the width of every level. How? Because if you have numbered the level, now every node is now numbered exactly how it should have been in an array, which means exactly, when I say exactly, it means it also considered this as null, because you ultimately see in the array itself, right? Here the null was also marked and it was 5. Here you can easily see null. It was also marked and have those indexes. Okay, it is 0, 1, 2, 3, 4, 5. So null have also been marked. So it's the reason that I'm very good to go. So by this, I can just grab the width of every level and I can just do a level wise traversal, and I'm good to go to find the width and ultimately find the maximum width of each level. But Aryan, it looks super fine. Okay, I'll just do a BFS traversal. If I start from the root node, as I move on to every child, I'll just assign the new numbers to those child, which means if my number is, let's say, 0, I'll assign the child number of me, my left child, as 2 into I plus 1 and the right child as 2 into I plus 2, and I'll just go on doing the BFS traversal. Aryan, it looks good. Let's code it down. But I'll say, hold a second. Did you see one thing? Did you see what can be the edge case here? If you clearly look, that number of nodes are 3000 maximum, which means if I just make a screw tree or kind of same to a screw tree, then what will happen? If it is 0, I made a screw tree like, okay, one side completely screwed, another side completely screwed, and okay, it's having only left and only right. Then what will happen? If it can have 3000 nodes, so the left side can have, let's say, 1500 nodes, right side can also have 1500 nodes. If I just go on to every of those level and use the same formula of 2 into I plus 1, 2 into I plus 1, and go on, you will see what's happening. 0, 2 into 0 plus 1, 2 into it's not nothing but 1, which is actually 2 to 0. So I just write it as 2 into 1 plus 1, which is actually nothing but 3. But actually, like, let's consider it is 2 plus 1 for now. So what will happen is 2 into 2 plus some part of this multiplied by 2 into 1 and something. I just left it. Okay, I just want to show you the what's happening inside. So you can see it's increasing. So at max it can go to 2 raised to power 1400. Neither your int nor long, like neither long int, nothing can hold this value. Nothing can hold this value. You see what's happening here? If you just go on by this method, while just assigning your child number as 2 into I plus 1, right child as 2 into I plus 2, it can just overflow because it cannot handle such a big value. So Aryan, what to do? Did you see one thing? What happened? What I actually want, I don't want this 3. I don't want this 6. I just want, okay, the difference should remain same, because ultimately what my purpose is the width and not the numbers. Which means although I assign the number 3, 4, 5, 6, why not reassign it as 0, 1, 2, 3? Ultimately, what will happen because of this is, if it is 0, then the left child will be 1, right child will be 2. You saw what happened. Your 7, it got reduced back to 1. And ultimately, I just reduced back it to 0 to actually go on to the next children. Which means, before moving on to the next children, I just, see, because of this 0, I just got 1 and 2. Ultimately, it is 2 into I plus 1 and 2 into I plus 2. But before moving on to the next children, which means before moving on to the next row, I'll just do a simple 0, 1. Now I will again do, it will just become a 1, it will become a 2, it will become a 3, it will become a 4. Again, when moving on to the next child, I'll just again do a 0, 1, 2, and 3. Which means ultimately I am bringing, I don't know why I did this, ultimately I am bringing my every number back starting from 0 itself, which means if I just clean it down for you guys, then you see what happened. 3, 4, 5, 6. Ultimately, I just brought everything down to 0, 1, 2, 3. By this, what you see will happen is it will just go on like 0, 0, 0, 0, 0. Thus, your exponential thing will not happen here. Thus, you will just be rid of our exponential thing, which means increasing 0, 1, 3, which was increasing exponentially in the power of 2. Now it will be exactly 0, 0, 0, and you don't have to worry about it. But did it solve the problem? Which means I showed you one thing, right? I showed you the left part. Did you think anything of the right part? Did you or did you not? I just showed you, okay, like Aryan, the left part is solved. I just make everything 0. But you see what's happening. Even if it is 0, it is going up till 4. It is going up till 2. It will go up till, it is actually 3. But let's say it is 4 in the power of 2. It will go up to 7. Let's say it is power of 2, which is 8. Right side can still go exponentially large. Did you think about it? For that, firstly, you understood, right, what's happening. If it is a 0, it will become a 1, 2, but actually I will rename that, which means I will just subtract the start value, because see, I just have the start value as 1, so I will subtract that start value from every of this level, which means -1, so it will become a 0, it will become a 1. Then again, when I'm doing the next BFS traversal, so the child will be 1, 2, 3, 4. Again, I will see, okay, what is my start like? See, I'm not subtracting 1, I'm subtracting my start. Why? Because let's assume that it had not been here. It would have started from here. Then I would have subtracted 2, because I want to make my start as 0 and not my initial node as like -1. I don't have to do. I have to make my start as 0, which means I have to subtract every number from that start thing and just reach. Cool. By this, I'll just go 1. It will become 1, 2, 3, 4. I'll just again do that as 0, 1, 2, 3. Again, what will happen is I'll do a 1, 2, 3, 4, 5, 6, 7. And ultimately it will become a 7, 1, 2, 3, 4. Ultimately, like on moving on to the next child, I will just again do a 0, 1, 2, 3 and so on, which means just we got the child values, but now again moving on to the next child, we have to subtract the start so as to make that as 0 and start from there. By this, I'm making my starts as 0, but we didn't see the right part, right? It could go big. What if in that case, which means your 0 had been made, but what if your right part would have been something like this? Let's assume in the last your number just reached int max, just it reached int max, which means 2 into 31 plus, let's say something is there, it is just reaching, let's say it is 30, it is just reaching int max, which means 31. I have not assumed, okay, it has something, but it will go on something because something will be added in its plus, because if it is being multiplied 2 into this whole part, 2 plus 1, 2 into 2 into 1 plus 2, then plus 2 itself. So you can see 2 into 2 raised power 1 plus this thing plus this thing. So plus will be added for sure, but for assumption, let's assume that it has just reached int max. Now, when you are doing, now although you know you will just make it as 0, you will make this number. You made this number like this only. It is at the level 31, let's say. Level can change, but let's assume, okay, it is this. When you go on to the next level, then you will simply do a 2 into my previous number plus 1, which means my parent plus 1, and 2 into my parent plus 2. You saw what happened. It was just int max. If it is just int max, 2 into int max will overflow the int, which means this number will overflow. The number right here will also overflow, which will exceed the int max. But you are given one thing, as I initially told, something as very important here. It is guaranteed that the answer will be in the range of 32-bit integer. I said it is very important. How? Let's see. If answer is it in the range of integer, which means the difference will always be in the range of integer, which means it can't be that, okay, here it is 0 and you have to find the difference with this value. It will say answer is always in the range of a integer, which means if it was integer, it exceeded integer limit, but it is for sure can come in the long. It can come in the long. Let's assume I placed them in the long, the difference of them, which is actually in the integer range. But if I place this long back to int, so it will actually overflow, because long, which is a big number, is actually placed in a smaller size of container, so it will just overflow. Again, this thing will also overflow, but the difference, it will actually remain same, which means the long difference and the overflowed int difference will actually remain the same. And this difference is exactly in the range of integer, and I'm just only concerned about this difference because I just want the width of my level. Although it can overflow, here it will overflow, but I'm just concerned about the width of this particular level, which is actually in the range. Although when it overflows, it will actually be a very absurd number because it is actually overflowed, but the difference will remain same. And you will say, I don't know, what if I have to go to the next level, because you say, okay, it is overflowed. See, it is overflowed. Okay, why I did? Yeah, it is overflowed, which means the number is not the exactly same what it is right now. It can be something like, let's say, minus 2 into something. 2 into 2 raised to power 31, let's say, like this. So when I am going on to the left and the right child, the value will change, Aryan. How are you handling this? I'll say, before moving on to the next child, I told you one thing. I'll subtract start from every of those number, which will actually make this number like 0, 1, 2, 3 back to the number again. Thus, I just made this number back again to this whole numbers. And again, when it goes on to the next child, it is actually having those numbers. And thus you will see, I just did a start index minus, so to actually get the actual node index. It can overflow, but I will just grab the actual value again before moving on to the next child. It is what we see, and you can easily see, I've just also explained, if it is int max, the int max plus 1. I did plus 1 because it will not assign the value. Int plus int will not work. Thus I have to change to long to actually add them, and thus it just overflowed. Next thing, added 1000, it just again overflowed. Again, I just pushed back to int. I just checked, okay, what is the value? The difference will still remain 999. Here also the difference would have been 999. That is the reason I just pushed back to int and I just choose not to choose a long. It was the thing which was not explained on the entire YouTube. Go on to the first, if you just search this problem, I'll just not name the person or YouTuber. If you just name this problem and go on to the very most viewed video on YouTube, it is not explained. Why? And firstly, the code might also be wrong. But it was not at all explained that why we actually need to do a 2 into long, which means putting that number to long and converting back to int, which actually will overflow, but the difference, which means the output result, is actually inside the integer and it will be perfect. It was not explained. You can just go and check on the YouTube itself. I'll not name anyone, so yeah. And let's see the code pretty quickly. We saw everything, how we will handle the edge cases of overflowing the int. Firstly, we saw, okay, the int is increasing a lot, so let's make it 0, but maybe it is starting in the, because it just goes from 2 to 0, 1 to 2 up till end also. Maybe there it goes to a big value. How to handle that? Because at a particular point of time, we are just concerned about the parent level and the next child level, because after that again this child level will again revert back to 0, 1, 2 up to so on. That is the thing which you have to think of this problem. Let's see the code pretty quickly. It's pretty easy. As I told, that firstly a base case always comes for sure. Maximum width, one node is always there, so maximum width full for sure start with 1. Queue will actually, earlier my queue used to handle one tree node, but as I said, a node is associated with a value, which means we associated a value with a node. A node, it will have a value, which means a number associated with it, because of which I will be able to say what is my left child's number and what is my right child's number. And again, like in the starting, I just pushed my root with the value 0. No worries at all. I have this as a standard BFS traversal. I just grab this queue, I just grab the level size, and I just iterate on this particular level. It is standard BFS traversal. If you have not watched our graph series or basically the problem tree series playlist, you can just go. We have just walked through this many times, like 100 times so far, so it's no worries at all. We grabbed the start index and the end index. Why? To find, because see, right now the queue is this. Start index and the end index of the queue will actually tell me what? The level width of that particular queue, which means queue dot front, which means the front queue pair, last queue pair, second is the number associated with it, which is the number which I assigned, and it is the number associated with the last element, which is the back of the queue. I just grab the width, I just updated my maximum width. Now let's move on to the childs. To move on to the child, I just grabbed, as simple as that, grab the front of the queue, pop that queue. But as I said that before moving on to, see, I just had this node. Okay, now I have to go on to my childs, but before assigning the value, I need to make sure I make all of them as 0, 1, 2, 3, so on and so forth. So I just did the same thing. I just grabbed, okay, what is the node value, which means if I just grab this particular node, so what is the value assigned to that node which I assigned, which is dot a second. I just subtracted the start which I grabbed from here, so as to bring it back to 0, 1, 2, like so on. Now I just grab this node index. My child index will be nothing but 2 into my node index plus 1. As I told you, if it is I, it is 2 into I plus 1. It is 2 into I plus 2 childs, if we have a left child, if we have a right child. Cool, no worries. And ultimately I just return the maximum width, which I have been updating for every of my level. I hope that you guys got it. Ultimately the complexity is nothing but O of n, a standard BFS traversal going on to every node. It is O of n. Space is also O of n, because Q being used in a BFS traversal uses a space of O of n. I hope that you guys liked it. Every code, C++, Java and Python is down below. I hope that you guys liked it. If yes, then do the like button. It motivates me a lot. And you can also go and check on YouTube if you find something like people have told, okay, we have to make it as 0 starting from, like, we have to subtract the start index, which means we have to make it like 0, 1, 2, so as not to overflow. But no one have told that why we converted that to long, then it converted back to int, because we are storing it an integer pair. So it is being converted from long back to int, and why it is correct, and why it's actually being stored in the int. It's actually being overflowed. So yeah, that's all from me. I hope that you guys liked it. If yes, then bye, take care.